Hey guys, in this video we're doing a tutorial on Ableton's Electric plugin, which is this guy right here. So it's one of the 3 physical modeling plugins that ship with Ableton Suite. The other 2 being Collision, which is more mallet based, or Intention, which is more string based. Electric is specific to simulating electromechanical or electric pianos like the Rhodes, the Wurlitzer and the Pianet. And it uses a technology called physical modeling. So instead of generating sounds by sampling the instrument or trying to produce it by generating waveforms that sound like the instrument, it's actually modeling and simulating the different components of how the physical instrument works. So each key in an electric piano has a hammer or mallet attached to it. And when you press it down, that hammer hits what's called a fork. And the fork is composed of 2 components. It has a tine bar and a tone bar. The tine bar is a very thin, hard piece of metal, and that's the thing that the hammer actually hits. The tine bar starts vibrating, and then the tone bar is a bigger piece of metal that is attached to the tine bar, and it's used as a resonator effectively to keep sustaining the sound. It's what actually determines the pitch. So different keys in the keyboard have different lengths of tone bars to create different pitches. So far we've described a fully mechanical system. So the electric component comes in what's called a pickup, and the pickup just translates mechanical or moving energy into an electrical signal that you can then amplify and then plug into an amp or something. And that's how you can actually hear the sound. So if you were to play the sound in the system I just described, you would effectively get a very long sustaining note. So to combat that, we have what's called a damper. So when you press down a key, the damper gets lifted so that the sound can resonate. And then when you let go of the key, the damper gets applied, which effectively kind of mutes the vibration. All right, so now that we have a mental model of how the piano actually works, let's look at the interface of Electric here. So you'll find that all the components I talked about are laid out here. So you have the mallet section on the left, which is this box here. Then you have the fork section here. Then you have the damper, the pickup, and then we have some global controls. So let me play a sound. This is what it sounds like when you first load it without touching anything. So stiffness is just how hard the mallet is, so you can move that around. So you can go from like a soft felty mallet to more of a metallic. And for this one, you can assign both velocity and keyboard. Next to that, we have a force knob, and that just determines how hard the hammer hits the tine. And again, you can just play with this. And again, you can assign it to velocity so that you could get different expression. The next section over is called noise, and this is the noise that is made when the mallet hits the tine. And you can change the properties of this, so you change the overall level of that noise. You can change the actual pitch of the noise and how long it takes for it to decay. And you can assign the level to the keyboard with this slider here. All right, moving on, we have the fork section over here. So if you remember, the fork is the piece of metal that gets hit by the hammer, and it's composed of the little tine bar, which gets hit first, and the tone bar, which is the bigger bar that vibrates and resonates. For tine, the color sets the frequency of the harmonics. So if you bring it lower, you get more bassier harmonics. And if you bring it up, you get brighter, higher level harmonics. Decay is the time for it to decay as you're holding a note down. And then you have the level, which is the overall level of the tine, which you can assign to the keyboard. Next to that, we have tone, which has the same exact parameters as tine. We have decay and level. And then finally, release acts on the whole fork, and that's when you let go of a key, how long it takes for the sound to fade out. Next to that, we have the damper. So if you remember, the damper, when you let go, is this thing that gets applied to dampen the sound. And you have a tone control, which sets the stiffness of the dampers. You have a softer felt damper on the left and more of an aggressive damper on the right. And you can set its volume here. And then we have this attack release knob, and this just sets how much of the damper sound you hear when you push down on the key versus when you let go of the key. So if you put it into the attack, you're only going to hear damper when you push down, but not when you let go, versus release where you don't hear it when you push and you hear it when you let go. Next to that, we get to the pickup. So remember, the pickup is the thing that takes the mechanical energy and turns it into an electrical signal so you can actually amplify it and hear it. So the pickup is placed next to the tine bar, which is part of the fork that gets hit by the hammer. So it's a very thin piece of metal, and then the pickup sits kind of next to it like this. And then there's 2 properties you can change, what's called the symmetry, which is the vertical position of where the pickup is. And then there's a distance, which is how far it is from the tine. So those are the 2 parameters we have here. Symmetry is the vertical position. So as you go down, you're kind of bringing it up higher. And if you go on the right, you're bringing it down lower. And then we have distance, where the larger the value, the further you are away from the tine that you're picking up. Below that, we have input and output. So input is just how much of the fork gets sent into the pickup, and output is how much of the pickup gets sent out to the output. And it's worth noting that as you increase the input, you get subtle distortion. So if you want a really clean sound, it's better to bring the input down and the output up. And if you want more of a distorted, kind of angry sound, then bring up the input and decrease the output. And then you can assign output to the keyboard here so that as you play higher, you get louder sounds. And then at the end, you have this RW switch. You can change the type of pickup. So R stands for Rhodes, and that uses the dynamic magnetic pickup. And then W is for Wurlitzer, and that uses more the reed-based static capacitive pickup. So you get different flavors of sound depending on which one you're trying to emulate. Finally, we have this global section, which is just general settings like the overall volume of the synth. Then you have how many voices you want from 2 to 32. You can adjust the semitones, detune it in cents. You can do stretch, so at 0% you get equal temperament, and as you bring it up, it starts stretching the overall tuning, and then you get the range of the pitch bend wheel. All right, so that's everything you need to know for Electric. It's a super simple plugin. There are no tabs or hidden menus or anything, and once you understand how the mechanics of the instrument works, the interface is actually really simple. If you like this kind of stuff, be sure to like, share, subscribe, and stay tuned for more tutorials, and I'll see you guys in the next.